This lesson is on finding an angle in a right triangle. The last lesson focused on how to find the side, and the first part of this lesson is going to look very similar, specifically the diagram with the SOHCAHTOA and our three formulas. That hasn't changed. I'll go over those quickly, and then we'll get to the meat and potatoes of today's lesson. In a right triangle, there's three sides that we are interested in. The hypotenuse, which is across from the 90-degree angle, the opposite, which is across from the angle of interest, and because today's lesson topic is finding the angle, instead of being across from the angle that we know, the opposite is going to be across from the angle that we want to find. And the adjacent is just that third side that's kind of just left over. Okay? Now, if you remember SOHCAHTOA, then there's no need to remember this. That sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, let's just get right down to business. Just a couple things. Remember that your calculator needs to be in degree mode. If you set it to degree mode previously, you don't need to change it every time you use it. It should still be on degree mode. And although we will not be finding the sine, cosine, or tangent of an angle today, just remember that when we did, it was the 4 decimal places. So the numbers that we get here will also be the 4 decimal places. So we just have to keep that in mind, that before we go ahead and find out the measure of the angle, make sure all of our work is the 4 decimal places. Okay, and you'll see what I mean as we go through the lesson. So here we want to find the value of angle theta to the nearest degree. So on our calculator, we're going to be using the same functions, sine, cosine, and tangent, with a twist. So most calculators, you'll type in the number first, so like the 0.7528, and then you would type in sine. But today we're going to do it a little bit different. Instead of just typing in sine, depending on your calculator, after you type in 0.7528, you are going to type in either, depending on your calculator, the second function button, or if you're using one of my classroom calculators, there'd be a shift button. So we have to press that second function button or the shift button before we press the sine button. Okay? Now, if you have a calculator where you type in sine first, then you'll start with that second button or the shift button, press and enter sine, and then type in 0.7528. So when you do that, what you're going to get is theta equals 48.8335. Now it says to the nearest degree, so that's to the nearest whole number. So because it's to the nearest whole number, that 8 is going to bump it up. So it's going to be 49 degrees. So the measure of angle theta for this angle or this question is 49 degrees. So please make sure you got that. If you got it, that means that your calculator is calibrated correctly and you're good to go. Now we're going to move on to the next one, which cos theta equals 0.6301. So again, we're going to have to use second or shift to help us out here. And then we're going to type it in. And when we do so, we'll skip to the part where we round to the nearest whole degree. We are going to get exactly 51 degrees. 51 degrees. It's actually 50.94249926, but of course rounded is 51 degrees. And last but not least, we're going to do this question here with tangent. So second function tangent, 1.1000. And in this case, when we round, we are going to get 48 degrees. So that's the answer we get for question C. So that's how we go about using our calculator to figuring out the angle given the value of sine, cos, or tangent. Okay? Now let's get down to business and let's do some questions. So here we go. Let's find the angle theta to the nearest degree. The first step in these problems is the first step we did last time, which is label the sides. So 12 centimeters right here. This is across from the 90-degree angle. So this is the hypotenuse. And 5.7 centimeters, it's across from the angle that we're trying to figure out. So it is the opposite. So we've got opposite and hypotenuse. So using SOHCAHTOA as our guiding principle, we know that we are going to be using sine. So it's going to be the sine of theta equals opposite over hypotenuse. Just a reminder from last lesson, sine is never over 1. So if you get something over 1, it means you put the opposite and the hypotenuse in the wrong spot. So just be aware of that. The opposite is 5.7. The hypotenuse is 12. What we need to do here is just a straight up division on our calculator. 5.7 divided by 12, and we actually get 0.475 bang on. Now, I did say we need to keep things to 4 decimal places, so it doesn't hurt to put a 4th decimal place there just to keep this good to go. Then what we will do is we will solve for theta by using second function or shift sign, and when we do that, we are going to get a measure of theta that's going to be 28 degrees, and that's rounded to the nearest whole degree. My calculator says 28.35935,003. And of course, when we round it, we get 28 degrees. So that's how we find the missing angle in a triangle, given that we have two sides of the triangle. Now, let's go on to the next question. Next question's right here. Again, first step, let's label those sides. So 56 millimeters. 56 millimeters. It's not across from the angle that we want to find, not across from the right angle. So therefore, 56 millimeters is the adjacent. Now, 180 millimeters, that is across from the angle we're trying to find. So that means 180 millimeters would be the opposite. So this question gives us the opposite and the adjacent. So that means we have, well, so, no, ka, no, toa, yes. So it's going to be the tangent of angle theta is equal to the opposite over the adjacent. So tangent of theta is 180, that's the opposite, over the adjacent, that's 56. As we go through this, just a reminder from yesterday, tangent is the only ratio that could be more than 1, and your spidey senses might be tingling already, telling you that if you divide 180 by 56, you will get an answer of more than 1, and you are right. So we take 180 divided by 56, and we get 3.2143. That is our answer to 4 decimal places, and then we use the shift tan feature, 3.2143, and what I get is, rounded to the nearest whole degree, 73 degrees. It's actually 72 point something, but that something is more than 0.5, so it bumps it up to 73 degrees. So angle theta is 73 degrees. Okay, so that's it for that question. Now we will move on to the next question. So we have this one right here. And again, first step, label the sides. So if we label the sides, we'll start off with 60. 60 is across from the right angle. Oh, there you go. So that means that 60 has got to be the hypotenuse. And 9 is not across from the angle we're trying to find, so it's not the opposite. So therefore, it's got to be the adjacent. So in this question, we have the opposite and, sorry, not the opposite, the adjacent and the hypotenuse. So that means that we are going to be using sine as so, nope, ka, yep. So it's going to be the cosine of theta is equal to the adjacent over the hypotenuse. The adjacent is 9, the hypotenuse is 60. When you go ahead and divide those, you'll get a terminating decimal, and you may add a couple zeros onto it, but quite frankly, we're only adding those zeros basically just to kind of train ourselves to write these to 4 decimal places. It's not needed. It won't impact your answer if you just write it as 0.15. Then we'll use the second function or shift feature, and we'll figure out that the measure of this angle is going to be, rounded to the nearest whole degree, 81 degrees. Wow, so it's almost a 90-degree angle. And if we look at the diagram, it kind of checks out. It almost looks like a 90-degree angle, so that makes sense. So the answer to this question is 81 degrees. Now this leaves us with one last example to do, and it's a problem because it gives us a diagram and we need to find an angle for it. So let's go off and take a look at that. So here we go. Find the angle indicated on the slide in the picture below. So what we know is the slide portion itself is 196 centimeters. The horizontal length of the slide is 152 centimeters, and we want to know what that angle is. So first step, let's label those sides. 152, it is going to be the adjacent. It's not the hypotenuse, and it's not the opposite, so it's got to be the adjacent. Now 196, it is the hypotenuse, because there is a right angle there, and it's directly across. So in this question, we have the adjacent and the hypotenuse. Now that should sound a little bit familiar, because the last question we did also had the adjacent and the hypotenuse. And in that question, we used cosine. So guess what? It's cosine again for us here. The cosine of theta is equal to the adjacent over the hypotenuse. So the adjacent is 152. The hypotenuse is 196. So we're just going to do a wee bit of dividing here. And we get 0.7755. And then we're going to go second function cosine on that. And when we do so, we find the measure of this angle is 39 degrees. That is a 39-degree angle between the bottom of the slide and the ground.